We have been conditioned to believe that Toyota is the brand of the sensible, the safe, and the terminally unexciting. We see these cars at school gates, at supermarket car parks, in the driveways of people who made their peace with practicality and never looked back. Beige. Invisible, forget-able by design. They are reliable, they are practical, and on the surface, completely, deliberately, aggressively ordinary. That is exactly what Toyota wanted you to think. Because under the bonnet of that people carrier, the one with the child seats and the scuff marks on the bumper, sits an engine that Lotus chose for their flagship sports car. An engine that produces Ferrari compression ratios. An engine that with a single bolt on modification makes 450 horsepower on completely stock internals. This is the 2GR, the most over-engineered V6 the automotive world walked past without a second glance, and the greatest performance engine bargain that has ever existed. Start with geometry, because geometry is where Toyota got it right and most of their competitors quietly got it wrong. The 2GR is a 60-degree V6. That angle is not a stylistic choice, it is the mathematically correct bank angle for a 6-cylinder engine. At 60 degrees, the firing intervals are perfectly equal, and the primary vibrations cancel each other out entirely. No counterbalancer shafts, no additional hardware. The engine simply does not shake, because the physics of it will not allow the shake to exist. Now look at the 90-degree V6, the layout that became standard across much of the industry. 90 degrees is correct for a V8. The geometry works beautifully there. For a 6-cylinder, it is fundamentally wrong. The firing intervals are uneven, the engine generates an inherent vibration it cannot cancel by itself, so manufacturers bolt on balance shafts to suppress the shake. Those shafts are added weight, added friction, a mechanical tax paid every revolution on every journey for the life of the engine. Toyota built the 2GR at 60 degrees and never needed to pay that tax. The valve train continues the same argument. The 2GR uses roller rocker arms, a design that belongs in competition engines. Traditional bucket-style followers slide against the camshaft lobe on every single revolution. Roller rockers roll. That one distinction eliminates a significant portion of parasitic friction, which means the engine revs freely, reaches its peak cleanly, and does not waste energy fighting itself on the way there. Then there is the block. Open deck aluminum construction, the same architecture found in engines built from the ground up for track use. An open deck exposes the water jacket at the top of the cylinder bore, allowing coolant to flow aggressively around the area, generating the most heat under sustained load. On a circuit, at full throttle for lap after lap, that is not a minor detail. That is the boundary between an engine that holds together and one that fails quietly and expensively from the inside. The injection system is where the later 2GR-FKS separates itself completely from everything else wearing a similar badge. Toyota calls it D4S dual injection, port and direct, operating simultaneously on every cycle. Direct injection sprays fuel at extremely high pressure directly into the combustion chamber. That efficiency enables a compression ratio of 11.8 to 1. Write that number down. Compare it to what Ferrari puts on their spec sheets. Then remember it belongs to an engine that spent most of its production life in a Camry. The well-documented failure of pure direct injection is carbon. Fuel never touches the intake valves, so oil vapor from the crankcase bakes onto them cycle after cycle, year after year. It is an epidemic running quietly through an entire generation of German performance cars. Valves so coated in carbon that airflow is measurably, demonstrably reduced. 50,000 miles in, 60,000 miles in, the engine you bought is already less than it was. And the solution is an expensive service interval Toyota customers have never heard of. Toyota's answer was to keep the port injectors, both systems running together every cycle without exception. The port injectors wash the valves continuously. The direct injectors maintain the compression ratio, no trade-off, no compromise middle ground. Both systems doing their job at the same time permanently. 11.8 to 1 compression, self-cleaning intake valves. In an engine sold inside a family saloon, the performance world built its theology on displacement. More liters, more cylinders, more iron. The V8 was not just a mechanical configuration. It was a statement about who you were and what you valued. Every theology has a cost. A typical iron block V8, an LS, a 1UZ weighs over 200 kilograms. The 2GR weighs 163, 37 kilograms of difference. In a front-engine car, that mass lives directly over the steering axle, pressing down on the front wheels, resisting every change of direction you ask for. Polar moment of inertia is the term for what that weight does to a chassis. The further mass sits from the car's center of rotation, the more force it takes to change direction. A heavy nose does not just add weight, it adds in inertia, resistance, delay. The car becomes something you negotiate with, rather than something that responds to you. You turn the wheel and you wait. Remove that mass and the character of the machine changes completely. Turn and sharpens into something immediate and direct. The steering begins to communicate rather than merely steer. The chassis stops lagging behind your inputs and starts anticipating them. A front-engine car with a lightweight engine can match the dynamic balance of a mid-engine layout. Not because anything moved, but because the front axle penalty was eliminated. The other advantage is the one no one mentions until the moment it happens. A V8 announces its intentions. The idle burble, the load bark, the physical authority of the exhaust note. It communicates exactly one thing with absolute clarity. You hear it coming, you know what it is. The performance is on the surface, visible, undeniable. The 2GR idles quietly, cruises without comment, sits in traffic, and blends into the background with complete conviction. Past 5,000 RPM, the performance world's most effective con artist stops pretending. The note sharpens into a rising scream. Urgent, high, utterly foreign to anything that looks like this car from the outside. It does not sound like a family engine pushed hard. It sounds like something built for a circuit installed somehow in the wrong vehicle. The person in the lane next to you never heard it coming. They never do. In 2021, Lotus unveiled the Emira, their first new sports car in over a decade, and the car tasked with defining what the company would be going forward. Lotus carries a singular philosophy: simplify, then add lightness. Every component that does not contribute directly to the driving experience is a component that should not exist. Weight is the enemy. Lightness is not a preference. It is a moral position. That thinking produced the 7, the Elise, the X-Ege. Machines that weigh almost nothing and drive like extensions of thought. For the Emira, Lotus needed an engine. They had access to bespoke units, European alternatives, purpose-built performance power plants with strong credentials and appropriate pedigree. They chose the Toyota 2GR. The most weight-conscious sports car manufacturer in Britain surveyed everything available and selected a V6 from a people carrier, not reluctantly, not as a budget constraint, as the correct engineering decision. The reason lives in one component that most owners will never see, and a part of the engine that requires no access panel and generates no warning lights. The crankshaft is forged steel, Cast cranks are adequate. They are what most engines receive, because most engines will never encounter loads that demand anything more. A forged steel crankshaft is specified when the engineers expect the engine to be pushed. When the rotating assembly will face forces that a cast component would eventually communicate in the most expensive way possible, were beyond its capability. Toyota built this crankshaft for a car whose primary use case was the morning commute. They overspecified it by an enormous margin and never mentioned it in any brochure. The consequence is that the 2GR will accept a centrifugal supercharger, a Harrop, a Magnuson, a Rotrex on completely factory internals and produce 450 horsepower, stock pistons, stock connecting rods, no machine work. No rebuild. The foundation Toyota engineered for a school-run vehicle was already capable of handling power figures that were never in the original specification. Because the rotating assembly is balanced with such precision, because the 60-degree architecture spreads load so evenly through the crankshaft, the engine stays harmonically stable at high revs, even under boost. It does not fight the additional load. It absorbs it, maintains its composure, and keeps making power cleanly all the way to the top of the rev range. As though this is exactly what it was always designed for. Lotus knew this. When they needed an engine worthy of their name, they did not go to Stuttgart or Maranello. They went to the scrapyard. The 2GR is not a rare engine. It is not a low-volume, limited production unit extracted from exotic vehicles and priced accordingly. It was fitted to the Camry, the RAV4, the Sienna, the Highlander, the Avalon, the Lexus ES350, GS350, RX350, IS350. For over a decade, if a Toyota or Lexus had a 6-cylinder engine, there was a very strong chance it had this one, which means there are thousands of them in scrapyards right now, pulled from written-off family cars, retired fleet vehicles, high-mileage SUVs, available to anyone who knows what they are looking at. The swap community understood this years ago. MR2 builders. GT86 owners who want to preserve the platform's weight balance but multiply its power. Enthusiasts who have done the maths and worked out that the gap between a 10,000-pound build and a genuinely fast car is smaller now than it has ever been. Cars built around junkyard 2GRs are appearing at track days and running down vehicles worth 5 and 6 times as much. Not because the builders have access to professional resources, because they recognize what they had before the rest of the market caught up. The engine through all of it remains indifferent to the abuse, oil changes, coolant flushes, the maintenance schedule of any ordinary Toyota. That is the complete list of demands. Run it hard on a Sunday circuit, let it cool, drive home. Be at work Monday morning. No crack block waiting to announce itself. No coolant contamination 3 services later. No unplanned rebuild as the price of admission for taking it seriously. Performance engines are not supposed to behave this way. They are supposed to extract a cost proportional to the performance they provide, expensive intervals, conservative service schedules, a background anxiety that comes standard with anything capable of genuine speed. The 2GR takes the track work, asks for nothing, and waits for the next time. Supercar capability, Corolla running costs, and an engine that costs less than a long weekend. The 2GR is not just an engine, it is an apology. It is evidence that inside the company that built the world's most sensible cars, there were engineers who refused to be entirely sensible, who took a minivan application, looked at the blank page in front of them, and decided to build something that could not be justified by the brief. They specified a forged crankshaft for the school run. They engineered a dual injection system that solved a problem German manufacturers still struggle with today. They built 60-degree balance into an engine destined for traffic queues. They laid a foundation so overqualified for its intended purpose that a company obsessed with lightness chose it over everything else in the world. They built something extraordinary, put it in something ordinary, and said nothing about it. Lotus found it. The swap community found it. Now you know exactly what has been hiding beneath 15 years of practical, sensible, deliberately unremarkable family transport. So answer this in the comments. Is the V6 swap the smart man's LS swap? The lighter engine, the higher rev ceiling, the handling balance that a 400 kilogram weight reduction buys you. Does that beat the torque, the sound, the uncomplicated authority of a big displacement V8? Weight versus power, physics versus character. Which side are you on? And if you want more stories about the engineering the automotive world quietly forgot to celebrate, subscribe. Because the 2GR is not the only secret hiding in plain sight. Not even close.